to have this video for those that are unable to join us. So thank you very much for all of you for being here. And the idea of this meeting is just to start really talking about science. The main goal is to see some short presentations for us in order for all of us to be clear what are we doing with seismicity, which part of our work is really related with seismicity catalog, and how these refined catalogs that we are gonna create can really impact in our research. No, Sebastián Riquelme is coming now. So yeah, we don't have it. Hola, Sebastián, ¿qué tal? We don't have any prescribed agenda for this meeting. It should be very relaxed. No, the idea is just to see that talks. And I don't know, Christian, if you have any idea, perhaps you can start from the Czech part of the project, and then we can follow on. No, first Czech Republic and then Chile, or perhaps we can do it as already as these small groups. No, we already find some small groups that are related with some topics. I don't know, Christian, what do you think about?
Yeah, I can actually start, because at the end of my presentation, I put these groups again. So maybe we can take that also as a reminder or as a first idea of how to structure things.
Yeah, great. So can you share your screen? And
yeah, let me do that. And then it should be this. Okay, share. Ooh, what's this? Okay, and this one, and slideshow. Okay, do you see the slide now?
Yes.
Okay, good. So first of all, for those who haven't seen me yet and don't see me now because there's no video connection on my call, this is me. I'm a seismologist who's currently trying to build up a working group in Prague here. And my main interests are in subduction zone seismicity at the moment, mostly concentrated on Chile, but that is planned to be slightly changing in the future. And most of what my working group does here is we're testing new machine learning based methods for building large scale catalogs from mostly permanent seismic data. And here I've also included a little presentation of Nasia, because she was going to also attend this meeting, but then had a short-term issue that, yeah, she needs to attend to, so she couldn't come. She's one of my PhD students, and her topic is in combining seismology with petrology. So she mostly aims at understanding earthquakes inside the downgoing slab. And for that, she's on the one hand using the data set from the IPOC deployment, so from the very north of Chile, for a local earthquake tomography study with a focus on the structure of the downgoing slab, because luckily we have there earthquakes that go all the way to 30 kilometers inside the slab, so we should be able to resolve this part of it. And on the other hand, she also does some petrological modeling to help interpret the velocity information that we find. This is roughly what she's doing. And what I did now for this presentation is I rather put together information that we already have, because the, let's say, new generation of earthquake catalogs that we're working on is currently not ready, but we can already use existing information, because most of what people here will be interested in is how to use this information in conjunction with other information. So one of the questions we should ask ourselves is, what information can we combine this with, and how do we do it? So there already are some big catalogs available. This is from a recent publication on the very north of Chile, the IPOC dataset that now has 15 years of permanent recordings and a catalog of more than 180,000 events, most of those actually in the downgoing slab. There's also the recent work of Diego Gonzalez on the region just south of IPOC, which is kind of the opposite approach in terms of station density and deployment time. So it's a much denser network, but a much shorter time period, which leads to a catalog with much lower completeness magnitude. So in this case, it's about 27,000 events within just 1.5 years. And here, interestingly, most of the seismicity is actually situated on and around the plate interface and not in the slab. And we also have a catalog that is even further south in central Chile. In the published shape, this one had about 11,000 events. I've recently extended it to recent times, and now it has 24,000. And what was highlighted in that publication is that there seems to be some relation to the presence of asperities that are apparently outlined by aseismic regions on the megathrust. So when we take this together, of course, this is not to say that these are the only earthquake catalogs available. There's the CSN catalog that covers the whole of Chile, maybe has somewhat higher magnitude of completeness, but in recent years, it's actually quite good. There are also many more focused catalogs on, for example, the Iapel aftershocks, the Valparaiso sequence. And also just now a preprint is out that looks at the area north and south of Mejillones Peninsula that kind of closes the gap that we currently have between IPOC and Anillo. And so what I tried here, and that will not look great because I just did it like an hour ago, is I turned Chile sideways because it has a terrible aspect ratio for a screen presentation. So north is now towards the left of the screen. And I plotted all the stations that went into these 3 different catalogs that I just showed. IPOC here on the left, Anillo Precursor and auxiliary stations here in the center. And here on the right side, the CSN, mostly CSN network plus a few auxiliary stations. And I tried to plot the actual earthquake distributions on top in a density plot. So here you see earthquake density per cube, and white basically means no earthquake. Then it goes from this green color to blue, and red means densest. And what you can see is what I already said before. In the very north of Chile, you have the IPOC data, and there the highest density of earthquakes is very clearly in the slab. These events are at depth of 90 to 110 kilometers. When we start from the other side, and unfortunately these colors are not perfectly matched because I had to account for different numbers of events in the different catalogs. So just take these as relative for each catalog, but the numbers don't compare because we're looking at different amount of years. So here in central Chile, we seem to have the majority of events rather at shallower depth along the coastline and not so many at deep depth. And now filling the...
Sorry,
yes?
Could you minimize the screen? Yes, that one. Please.
This thing, yeah.
Yes, thank you.
I wasn't sure whether you actually see that as well. Okay. Yeah, better? Good. And lastly, if I fill the gap in the middle with the Anillo Precursor catalog, we see that this seems to rather continue the trend from the central Chile, that most of the events are along the coastline, and then there's a second but less less big or less pronounced concentration of events at deeper depth. This is of course just a very rough plot that I made in the last couple of hours. One could and should do this in a better way, but this was just to illustrate that we already have quite some usable data. So we don't need to wait until there are maybe new earthquake catalogs, but we can already, with the existing material, think about how to evaluate them, what to combine them with, and how to do that. And I think that's my main message. So here, and can I also move this thing? Yes. Oh, no, that was not supposed to be. Yes. So here is a very quick summary. Even with separate catalogs, or we could actually use do something similar with the CSN catalog that has maybe more homogeneous catalog, but also a pronounced gap where the ANEO precursor deployment was. We can already think about how to visualize certain aspects of seismicity and what to compare them with. And there's a few obvious things, and that were also for some regions already done. Like, for example, cross-plotting plate interface events and coupling maps. Something similar could, for example, be done with offshore gravity and so on. And maybe it might make a lot of sense to use this meeting to also brainstorm what of these things would make sense. And here I just copied in what was already sent around last time, I think, which is the preliminary and proposed division into subtopics that we came up with. And I think we can take this as a starting point and maybe modify or define like more clear routes for the different topics in the following discussion. And that's everything from my side. Thanks. So should I still keep this on screen, maybe? Or should I unshare?
I don't know. I think it could make sense to use this momentum to discuss that, actually. Yeah. So the point is because we have several people that will also present some particular aspects. But
so maybe it also makes sense to come back to it at the end.
I don't know. Yeah, perhaps.
Okay, then I will simply unshare and we
let's
first.
try to see what people would like to say about their research, and then we come back. So let's try to have at least 15 minutes to discuss, I think. So that means we have half an hour, perhaps, to see the other presentations. Yeah. So it's supposed to be 5 minutes each. Let's try to do it quickly. Yeah. So to end up with the Chess side of the project, can you, Jorge, share your screen and show what you have prepared for us?
Yes, sure. Can you see my screen?
Yes.
Okay. Can you still see it?
Yes.
Okay. Well, I didn't prepare anything. I just took some slides from a previous seminar that I gave. So I will try to do it as fast as possible. I will probably skip some slides. The title is even in Spanish. Avances en algoritmos de asociación de fases sísmicas y resultados comparativos preliminares. Yeah, basically what I'm working on is on seismic phase association. This is mostly an introduction on why are we focused or interested in microseismicity. And I think this image clearly explains why we are using microseismicity. So the upper part is, these two are images generated by global catalogs, by using global catalogs. And the lower part are two images using local seismicity. So in the left, we have data from IPOC seismic network. And yeah, so we can have access to more events, more arrivals that translates into better location precision of the events. And we can even see some geological features in those from those events from that data. So the standard earthquake monitoring workflow is divided in different steps. The first one is the detection of the impulsive arrivals, which is the phase peaking. The second part is the association of these arrivals between the stations that are coming from the same event. So that is the part that I am working on. Later, we can infer the location and the origin time and estimate the magnitude. That is how we usually generate the seismic catalogs. Yeah, so far there has been many improvements in face picking. So in the first part of the workflow, there are many deep learning based pickers, and they are now available in a platform that is called SizeBench. So in this platform, we can easily use each of these pickers and apply it to our data. And all of them generate large volumes of picks, and they are capable of differentiating between P and S faces. So the seismic phase association, as I said before, is a process that links together the seismic phases that are triggered in different stations in order to declare an earthquake. So it is just something like what we have here. We have many events that are probably occurring at the same time, and the waves are traveling to each of the stations. And on the computer, what we have is something like this. So like a mess, and the point of this task is to cluster each of these arrivals if they come from the same earthquake. So to date, this task, the phase association, is usually done by algorithms that are based on a grid search. And there has been some improvements in phase association and the last years, but not so many as we saw in the phase pickers. So in the phase association, we have a few algorithms. One of them is Gamma, the other one is Real. I will not talk about some features of this, but they work differently. So they are different approaches. There is also PhaseLink, which is another completely different approach. This one is based on deep learning. And yeah, I will not speak about that. This is something that I did where I was comparing the iPod catalog of 2012. So these are the events on the left. And on the right is the same data, but I used Earthquake Transformer, which is a deep learning based picker, and PhaseLink, which is a deep learning based associator. And what we can easily see is that on the right, on the deep learning based method, we found more than the double of the events. And yeah, but still we don't know if these are real events. So then we decided to make a comparison of the different associators, but using synthetic data, so that I can have more control on my own database. And I compared 3 different scenarios. The first one was mostly to check the behavior of the different associators with increasing the amount of noise or the amount of false peaks. Then I analyzed 2 other scenarios simulating a background seismicity case and an aftershock seismicity case. The first scenario, or the first analysis that I did, was related to the amount of false peaks. So what I did was basically I created 100 events, and I was increasing the amount of false peaks by increments of 25%. So here we can see the behavior of each of the different associators as we increase the level of the noise. So yeah, to sum up, Gamma and Real, these 2 are more or less stable compared to PhaseLink, that its performance is dropping very soon. Yeah, this is another analysis based on the true peaks that each of the associators were using and things like that. This is the other scenario that I simulated. So this is 100 events and 250% of noise or false peaks. And we can see how each of these associators behave in these scenarios. So yeah, these colored peaks are the peaks that were recovered of the synthetic data. And we can see that phaseling is the one that is more affected with more false peaks. Then we have the last scenario that I analyzed, which is a kind of aftershock seismicity, where we have events that are more close to each other, like here or here. And we analyze the performance of the different associators. And here we can see that phaseling is improving a bit, not as much as the other ones, but it's improving. Yeah, so to sum up from this work, gamma and real appear to be more robust against false peaks. In the next months, I will be doing a systematic evaluation of the effects of the parameter variations on the performance of each associator. So I will take some similar parameters that hopefully they have, and yeah, vary these parameters and see how they behave. And later I will create a workflow to apply to our data set, and later another colleague, Nasia, will be working on seismic tomography. And the plan or the idea is to integrate these associators into SeisMench, the platform that already contains these pickers, so that we can have like the whole workflow in one site. So that's all. As you can see, what I'm doing is mostly on more technical things on the association part of the generation of the catalogs. So that's all.
Okay, Jorge, quite clear. Thank you for being on time. Yeah, can you stop sharing the screen? Thank you.
Yep.
Hola, Marcos. So that was the, yeah, bueno, no problem. That was the test part of the project. And let's start with the Chilean part. And let's start with the only woman that is here with us. Thanks, Ignacia, for being here.
Hello. It's very confusing to have a Nasia and an Ignacia in the same project.
Yeah.
Like every time that they say Nasia, I was like, me? Oh, no, not me.
Yeah, it's you,
Yes.
because Nasia
Yes.
is not here. That's a good thing.
Yeah.
So please go ahead. If you
Okay, so I think the most outside of the what you are presenting, but I have a student that she's working on the 1922 area, and we are basing on what was happened for the 2014. So I will share just some slides that I as Jorge recycled from other presentations, so maybe looks weird, but the thing is, what we are trying to do is what I will show you. And as I see until now, we can use your input, so will be very nice. Just 1 second. This one. So, do you see my screen? Yes.
Yep.
And this one. So,
Yep.
nice. So just to put this is the 2014. So just to put the background, there were a lot of series of swarm beginning the 8 months before the earthquake. So we want to see the seismicity around the 1922. That's what my student Francisca will do. And also there were a seismic slip. So we want to see if something similar, or what is the state, well, the status of the seismicity now in the 1922 area, taking this in account. Also, wait, doesn't move. Also, there are some students from studies from Soquet that is also doing Martín Sepúlveda from the geological PhD, your PhD, yes, that is working on these slope slip events that could be some, we don't know, but we want to know if there is some of them in the same area, and if this, for example, could help to keep the 2014 in that area and not longer than. So we want to see. So we are based on this. And also what features control the area. As for example, for the 2014, there is a study that showed these sea mountains. So she's looking for Gearsen work if she found something about something in the structure. So I took like maybe from the earthquake tomography that NASIA is doing, maybe we can see something in the same 1922 area. And also the gravity anomalies that Andres will present later, I assume. So, because here also there was a change just in the limit of the 2014. So we are taking this as a base to see what we could find in the 1922 and using the coupling. It's not 2017. I didn't erase the date, the year. So sorry. So using these and all the other features to build a next earthquake. So the question is where we just, for example, where we just put the limit for this one. We have the main part here, but where we could put the limits. So that is why we are looking for the entire picture and not only with the coupling. So that is what I think is related to this group that we are doing with my students.
Okay, Ignacia, thank you. So what you are interested in is trying to map the asperities in order to create earthquake scenarios that then can be inputted into tsunami scenarios.
Yes, yes,
Mhm.
exactly.
Yeah, okay, perfect. So let's advance. I don't know, Sergio, Sebastián, or Marcos, do you have something to share with us? Are you prepared for that? Perhaps Sergio or Sebastián first.
I don't have anything. I haven't talked to PacLab in a few weeks, so I think for the next meeting I can have something.
Yeah, okay. But can you tell us a little bit, as in a minute, what are you doing with Basculac?
Yeah, we installed like 10 sensors in Santiago for specifically for earthquake early warning, and we are testing his method with he used machine learning and phase association in real time for earthquake early warning. So we are trying with those 10 stations if that works or not. And we are creating a catalog of events here in Central Chile, but with just 10 stations. And eventually we will include the National Seismological Center stations in the near future. That's the plan.
Yeah, perfect. So thanks for sharing. Sergio, do you have?
Yes, yes. I can show you some pictures and explain a little. We are working in the similar idea. Actually, we are now working in a method to using some different methods to localize small seismicity and also to do some association. But we have many works that maybe could be useful. That is the work mainly from Bertrand Potin and Florent Aden-Antenois, that are two younger researchers. And with Bertrand did 3D tomography for all Chile that he finished. And also we have a catalog that I expect to publish now, but now I sent this catalog that is in this picture to a review journal that asked me for a manuscript, and after 1 year they reject because they said me that is so new to do a review. Then we have the problem, we have many results that we don't publish now, but I expect that publish very soon. And in this work, we localized all the CSN catalog from the 2000, around 20 years of data. We can see some profiles. Also, we do several studies. Also, we studied the p-value, but also Florent Aden and did some identify many clusters around the Chilean subocean in different parts. We have these results, also the tomography. I hope to available very soon, but my problem is we are very slow to publish. But we can collaborate, we can share for the moment. If not, we can expect a little to publish. I will send to try to do some very fast journal, I don't know where, but for me it's not the, but Bertrand and Florent are very young researchers and they need this published. So, and also we are working in some parts, we are some deployed stations, we are doing some relocalizations. We are now very interested in the part of the La Serena zone. We are working there. And also I work some work in the intraplate intermediate depth seismicity to understand the source, which is the difference there in the slab of the Nazca plate, and also what is the difference in the seismic source to the event that will occur in middle of the Nazca plate. No? Then I think that this is the main thing I am interested in. Yes, we have this that I don't know that many of us are working in some similar thing, but I hope that we can collaborate in some part. And actually, I expect that at this moment this was published, but we are very slow now. But we can share if it is necessary. I don't know. We can speak. This is for my part.
Okay, Sergio, thanks for that. And just to be clear, that seismicity, it's only from the CSN data.
We have more data because at some moment Bertrand asked many people for the data of the temporary deployments. But in this picture is only the CSN catalog because I think that it was more faster to publish it, all the localized CSN catalog. But we have more data in the Bertrand works.
Yeah. Okay.
We have many work, but the problem is we are not published this, and now I don't know how to publish all this fast.
Yeah, I see. We can talk about that later. Thanks, Sergio. Marcos, would you like to...
I didn't have time to prepare anything, so
Sorry.
maybe next time. I has been also working with Christian in updating the catalog in Central Chile. With another colleague, Juan Carlos Baez, we also updated the time series of GPS.
Mhm.
And we have a logging map that is from the central Chile, and we are trying now to compare with the seismicity.
Yeah. Mhm.
But I haven't made any figure yet. So
Yeah, don't
maybe
worry.
next week
No, don't worry. But most of what you are doing is try to update the work in central Chile with the extended seismicity catalog and extended time series for GBS, no?
Yeah,
Great.
what we have done. This is something that I need to show in Corsica. So
Yeah.
I hope
We'll
to
see that
have
there.
some results the next day.
Yeah, I know. Yeah, but something that we will see. I mean, Sergio and myself, at least in Corsica, so we can also include it in a discussion there. Yeah, great. Nico, do you have something to show to us?
Yes, I have some pictures.
Yeah.
So let me know if you can see my screen.
Yeah, I can see
Okay.
myself there. Unfortunately, I don't like it.
And what about now? Can you see the?
No, still seeing my ugly.
Okay. Let me. Sorry, a little patience, please. My computer is not so new. Okay. What about now?
Yeah.
Yeah.
Now we're
Okay.
seeing. Mhm.
So I will show you some results on the topics of interest of our work. So as an introduction, we are working in the Atacama seismic gap, and the red triangles represents the stations associated to the Anillo network. With the data collected for 18 months, González Vidal obtained a catalog composed by 3,000 seismic events. And I'm using basically that catalog to create velocity models and seismic tomography. So as results, we have a one-dimensional minimum velocity model, and this one, the red line is our result compared with an initial velocity model related to. Oh, sorry, the citation is not showing. Houston 2000, more to the north of the area. There are some differences, of course, but the important thing is that we have the minimum velocity model, and we use this model to create as an initial step to create a two-dimensional BP and BP to VS models, and we got this. This is our two-dimensional velocity model. We can see that there are some important features for us. For example, that the seismicity used correlate especially with the place where we expect to have the slab, and the BP to VS values are related to that expected areas. And using these two dimensionals BP and BP to VS ratio models, we created a 3D tomo, and it's done now. So I'm going to show you some one profile because of the time, and this is more or less what we got for this specific profile that is showed in the red crosses to the right of the screen. And the seismic events are the black dots, are from the a plant view. It represents the same seismicity in all the three pictures. So it's the same. We can see some interesting features again, that the high BP to VS ratio values are under the slab 2 contact from H, and the seismicity is quite related to that structure. And that's for this single profile. For time, I'm not showing more of them, but and current work, now I'm working with events relocation, trying to understand how for the same profile, how the seismicity is changing in the case of using a one-dimensional, two-dimensional, or a three-dimensional velocity model for the same SWOT or window from the profile. So this is more or less what we can see from the one-dimensional and two-dimensional, and the bottom the three-dimensional velocity model, trying to understand and improve the residuals and the root mean square for the hypocentral locations, and that's what we are working now with the initial catalog. And another results are that we have more or less defined the entire resolution area for each profile and for the two-dimensional velocity models. So that's all from my part for now.
Quite clear. Thank you, Nico. Can you stop sharing? Yeah, thanks. Perfect, super good. Yeah, I will try to do it in 3 minutes. Yeah, just because I have that prepared already. And let me see, where is my presentation? I don't know. Yeah. Let's see that. Yes. So here is what I have. Can you see my screen? I think so. No. Well, okay.
Yes.
Well, I also yeah coded a little bit a talk that I had previously, just to show our interest in the crustal size, the relation between crustal seismicity and rheology. No, that's what we are doing with mostly with Martin Riedel. Yeah, if you look at any crustal cross section with seismicity everywhere in the world, here in the Andes or in San Andreas Fault, you can see that the seismicity cut off depth, no? So the depth at which the seismicity disappears, it follows some tendencies. And here you can see, if you are in one point below the Earth surface, you can always construct a diagram like this. It's an histogram with the cumulative distribution of seismicity with depth. And from this, you can define the seismicity cut-off depth at any depth. In this case, is where 95% of the earthquakes are located. And the main question is, well, what's really control the seismicity cut-off depth? In terms of rheology, you will see that the SCD should correlate with the brittle ductile transition, because that's the point where the brittle yield strength intersect the ductile yield strength, and it is controlled by many physical parameters, but also it's mostly controlled by temperature, because the ductile yield strength is controlled by temperature. So that means with a particular temperature gradient and with a particular rheology or composition, you will have a given BDT that should relate with the SCD. If you increase the SCDs, if you have a deeper seismicity cut-off depth, you will expect that the temperatures are lower. No, for instance, you can reduce the surface heat flow from 90 to 55, and with the same rheology, you will have a deeper BDT, but the same is true or keeping the temperature at the same level, but changing the rheology. With, in this case, a much stronger rheology that with the same temperature will have a deeper BDT. So the point is that the SCD, the seismicity cut-off depth, can be related either with changes in temperature or changes in rheology. And in order to understand that, what we are doing, it's we computed the SCD for the Andes. We also computed a thermal model and make an assessment of crustal rheology. And that is what Martin has been doing mostly. We have a paper that was rejected at the first moment, and we are working in a new version in order to compute the ECD from the seismicity catalog of CSN, just taking the catalog as it is. I have to state that Martin is not present today because he's in the field, But well, that's part of the work that Martin is doing. Most of what Martin will do during the PhD is the relocation of all the CSN seismicity in order with machine learning algorithm in order to produce a new catalog. And he will use the catalog mostly for understanding of processes that happen in the slab, not in the crust. But the work with the crustal seismicity, it's myself and some other students who will keep on working on the interpretation of the seismicity, crustal seismicity catalog in terms of rheology. And well, what we did here was to produce a map of the SCD, which is the one here. No, that's actually the seismogenic thickness is the difference between the SCD, which should be related with the VDT, and the seismicity once at depth at the surface. No, but we will concentrate it in the SCD map. And we created also a 3D thermal model for the Andean margin, just using some constraint about the geometry of the margin and some one-dimensional approach for that, but get into three-dimensional distribution of temperatures that we compare here. For instance, that's the map of the SCD with the temperature at the SCD. We can, because we have a three-dimensional volume of temperature, we can assess what is the temperature at the particular depth of the SCD. And if you plot that in SCD against temperature at the SCD, we end up with this kind of graphs, no? And colors here means the surface heat flow density or heat flow value at the surface, no, for each of these points here. And we can see that we have very cold situation and very hot situations. Most of the data are in between these. But what you will expect here is really that for the same rheology, you will have more or less the same temperatures. So this variation in the scattering of the values really means that crustal rheology is also playing a role. It's not only temperature, because if it's going to be the same rheology, you will have more or less the same temperatures also to explain this variation. So that means that rheology also play a role. What we did was to obtain for each SCD at each temperature a range of different possibilities with different compositions for the yield strength, and we selected the one that is really most closer to the SCD, and with this we produce a map of the rheology of the lower crust. Without entering in any detail, this map is very interesting because allow us to see what's the most probably rheology of the middle to lower crust. And we can compare this map, for instance, with the geological map, most precisely with the geological map of the basement that should be mostly related with the wool structure of the crust. And what we see is that there is some correlation actually between these changes, mostly the north-south changes in rheology, that seems to be also related with changes in the surface geology of the upper crust. So yeah, we think that this is interesting because allow us to combine seismicity cutoff depth with temperature and rheology, and we see that this relationship between the seismicity cutoff depth and temperature can be used to map rheology actually, and that we need a better seismicity catalog for sure in order to amplify our coverage of the Andean crust, and a better thermal model. That is something that we are also working over these days. So that's all what I have to say. Sorry for being so fast with that, but okay, so now we have some time to start discussing. Christian, can you come back to your first to your last slide where you show the different groups or working groups that we can create?
Okay, yeah, I'll bring it up. And that was first. Whoop. Where is it? It has disappeared. No.
Which one?
Slideshow. Here.
So great.
That's visible to everyone again? Yeah.
Yeah.
Okay.
Yeah. Can you go ahead with the discussion based on this slide, please?
Yeah, I think the idea we had last time is that we can, because we're quite a few people with not always completely overlapping interests, that we can subdivide ourselves into a few smaller groups that can then maybe meet for more, let's say, specific discussions. And the initial setup that I think I put on last time, and that was then modified a bit after people gave me feedback where they think they belong or don't belong, is this one here. So among these topics, when we look at them, there's one topic, the early warning topic, where Sebastian and Václav are kind of a collaboration on their own that is not going that much together with everything else, because everything else is not really in a real-time context. However, Jorge would also be interested in getting into real-time algorithms, so he was also volunteering to get onto that. So that's kind of a little mini group on its own. And also what we have here at the end with crustal seismicity and rheology, at the moment that's just Martin and Andres, who are PhD student and supervisor anyway, so maybe we don't need to have this as a specific group for longer or more focused discussions, because you probably interact anyway.
Yeah, that's true. I mean, if somebody is interested on joining us,
Of course, yeah.
It's very open, and we will be very happy also to collaborate with somebody. But it's true. I mean, we are working in a very specific topic with that. No, it's how to take advantage of the seismicity, crustal seismicity catalog. No,
so I guess what we have now on the one side is the more technical stuff about how to maybe employ novel methods to evaluate seismicity, to retrieve catalogs on the one hand, and then the, let's say, usage or combination of seismicity information with other observables on the one hand for the plate interface and on the other hand for the slabs.
That's right. Yeah. Yeah, I think that's leaving out those topics that are more related with specific work that 2 or 3 people are doing together, like early warning.
Well, I mean, with the early warning topic, I think it would make a lot of sense if people also meet, but maybe it will happen anyway, and I'm not sure if it needs to go through this whole procedure here. Of course it can, but
yeah.
And of course, it's still somehow related because the types of algorithms, so it might be somehow related to the first topic here, to the technical stuff, because it can be similar algorithms that then get applied in an early warning context.
Yeah. I don't know if somebody would like to comment on that, or to comment on I mean, if these topics that are there really cover all of what we are researching or our interested. Well, that was discussed in the last meeting, but in order to advance a little bit, because the main idea will be to leave these people to meet, to plan meetings in small groups, and try to advance a little bit on this research before November, before the Geological Congress, where we all will try to also to meet. But yeah, I don't know if somebody would like to comment on that. Because if that's not the case, what should be the next step?
Maybe we should somehow organize or appoint who for each group organizes the meeting, because if we just leave people to organize themselves, there's a pretty high chance it doesn't happen.
That's right. That's right. So yeah, I think that perhaps we can lead that. I mean, one group can be led by you and other one by me, and try to put some dates on, or some schedule for these small meetings.
Yeah, it's not really about leadership. It's just somebody has to initiate the process of setting up a date. And then,
Yeah, but I mean, that's what I mean. Yeah. But yeah, I don't know. Perhaps people don't like the idea, or don't want to have too much meetings. And
yeah, well, we shouldn't do too many, I guess. That's also true.
yeah.
But yeah, what you said, one before Congreso might make a lot of sense.
I think that makes sense. No, makes sense to have something before the end of November. No, so that give us 2 months to work on that. I mean, at least one meeting. No, one meeting, thinking on how to really to work together. I think that there is one topic that we can discuss now. And Sergio mentioned that already, which is that many of us are interested in the same topic, in the same research topic, which is the relationship between intra-slab seismicity, the thermal state of the slab, or changes in temperature, or in fluid content, etc. No, but that are based on using the seismicity catalog, the intra-slab seismicity catalog. So I think that one topic would be how to work all together, no, in a topic which is of interest for all of us. And at least in our case, for instance, we have one PhD student, so Martin for our case, Nasia from the Czech part of the project, but Sergio also have some students working on that. And so if we don't have this project together, we will be competing probably for the same paper, so to say. And I think that's good that we are working together now in this project, and that give us the opportunity to really to define who is going to do what with which data, and with focus also. So that's something that I don't know if that's now the moment to discuss that, because we don't have the time. But it's something really to have in mind and to discuss it. I will say as soon as possible. I don't know, Sergio, what do you think about that, and also Christian, if that's really an issue or not?
I think that maybe during the Geological Congress, if we do a meeting,
yeah, we should definitely meet in person.
Could be a better to discuss this topic.
Yeah, but let's try to advance a little bit before the Geological Congress with just one meeting in this small group. I mean, no, so this small group topic.
Also, to make things maybe a bit easier to organize, we could also say, because now that would already mean we have to organize 3 or 4 meetings. Alternatively, we could also just organize one date, and then the first, I don't know, half hour or 40 minutes is for the one topic, the next 30 minutes, 40 minutes is for the next topic, and so on. That we just need to find one date, and people can come in or drop out according to topic.
I think it's a better
idea. Might be a bit more easy to get.
Yeah, because several of us are included in more than one group. That's right. Yeah, you are right. No, so let's try to organize a new meeting. I don't know, perhaps in 1 month, which is gonna be, or at the end of November, at the end of October. That will be 1 month before the Geological Congress. And
let's do that, and then it would also, I would be very interested in maybe having 5 or 10 minutes, if people still have it, for asking some questions to the presentations that were shown.
Yeah. So I think that we can if you can just stop sharing.
Yep.
I think with the first point, which is having a new meeting to talk specifically about how to work together in small groups or with the small research topics, is something that we are going to do. No, if somebody do not agree with that, please say it now. But if not, we will put another survey shortly now in order to find a specific date for that meeting at the end of October. Yeah. Okay, we agree. And yeah, the other topic, if we can just have 5 minutes or 10 minutes to talk about the presentations, like as Christian said, no? If somebody has specific questions about what we already saw. Yes, Sergio, please.
But I have a little lost. Before or after the Geological Congress, we have a meeting in person in some part in Santiago. This is
Yes.
agree or not?
Yeah, that was the idea. Yeah. So during the Congress, we have this special session, or this session, which is led by you and Christian, I guess, and Sebastian, I guess, also. Yeah, that will be also an opportunity to meet during the Congress. But as far as I remember, Claudia, the idea was also to meet, also to have a meeting, in-person meeting, only this group of people or those that are going to be in Santiago, after the Congreso or before the Congreso. That's something that I don't remember.
I think we didn't really specify it, but I would be also very interested to visit Sergio and his group. Probably best is just before or just after, because then I'll be in Santiago anyway. Or I haven't really checked the program of the Congreso. Maybe there's also, well, if there is a day that we both don't find so interesting, we could also put it inside the Congreso time, but otherwise let's do it just before or just after. But I haven't really worked out my schedule in detail yet, to be honest.
Yeah, I would say that for us, people living in Concepcion, perhaps will be not so easy to just to stay after the Congreso. At least for me, will be not easy to stay after the Congreso or come days before will be also complicated, because we will gonna be at the end of the academic semester. So leaving Concepcion is hard for us. And in that case, perhaps we should prefer meeting during the Congreso. I don't know that not everybody is going to be in the Congreso, but like Christian said, we can check the program. The program is not ready at the moment. It's being produced by the organizing committee. I think that probably in the next couple of weeks will be released. But I'm pretty sure that for us, the group of people that we will find plenty of time really because the Congress is very geological, no? So I'm pretty sure that at least half a day between Monday and Friday will be completely free for us, and we should plan on that, no? So once the scientific program of the Congress is ready, perhaps Christian and myself can analyze it and suggest 1/2 day time for all of us to meet during this week. No, what do you think? Yeah, Sergio, perhaps that answer your question.
Yes, I don't have problem. Maybe we can fix soon as soon possible.
Yes.
And also is we are meeting in the Congress or in the Catholic University or in the Chile University.
I don't think that in the Congress venue, because it's so far away for everybody. No,
Yes.
We should meet perhaps in Buchef or San Joaquin. I don't know. Probably Buchef is much easier to get also for those of us that will be in central, in the downtown. I will be in Providencia actually. But yeah. So let's, as I said, so once the scientific program it's more or less clear, we can make an assessment of what will be the best half-day window to meet all together, and give you some hints and give you a suggestion of these possibilities. Yeah. Great.
Okay.
Super. Yeah. I don't know, Christian, because we opened the time for scientific questions about the talks, but so we could have so many to say or to discuss about that, because there were many different topics, no? But I don't think that we have the time for that. Christian, what do you think?
Yeah, probably not. I don't know. Maybe we can also leave the next online meeting for more detailed questions. I don't know.
Yeah.
Or how does it look for everybody? If everybody still has 10 minutes or so, we can have at least a little bit of a discussion.
So, at least in my case, I have time now. I have until, well, I have 20 minutes more. But I don't think that if people really have that time or interest at this moment to discuss about the scientific aspects of what we were presenting. Yeah, do we have time?
We have time to 1 o'clock.
Yeah.
I have to leave like 5 to 1, so it's okay for me.
Okay, perfect. If we can stay here another 15 minutes, I think will be interesting. So Christian, probably I think you have some points.
I definitely have some questions, yes. Okay, then I'll just start. Sergio, I was very interested in that relocated CSN catalog that you had, because just looking at the cross sections you showed, they looked quite a bit better than the raw CSN catalog, I think. In that image you had, in all the cross sections, the slab looked more or less straight. Is that just because of the choice of the cross sections? Like, do they just happen to be in the areas where the slab is straight, or is that something in the velocity model that gives the slab like the hypocenters of the Wadati-Benioff zone a more straight appearance than they might really be?
Yeah, no, I showed the profile where we look better the seismicity and depth, because where we have more good data, that is in the northern Chile and in central Chile. There we have more data, better relocalizations, and like in this part we use only the CSN catalog. We have good solutions for events around 100 depth, not too much. Then all the seismicity that is below mountains in the Argentine side is very bad. Actually, we don't see in this part, for example, the flat slab, but only for the bad localization.
Okay, makes sense.
Yeah. So that means.
And did you relocate really all events, or did you do some quality selection? Like, did you throw some out of the CSN catalog?
Well, we did actually. Bertrand did a tomography using CSN data and all the data we can obtain for temporary deployment, and he did a joint tomography inversion and also a relocalization. Then, in this case, we think that it was more easy to put only the CSN catalog that is localized in the 3D tomography and also with a double difference relocalization.
Okay, so what you showed is the same amount of seismicity that is in the original CSN catalog. Like, more or less everything was relocated.
Yes. It's only the CSN seismicity, but relocalized.
Okay. Yeah, thanks.
And adding to that, the relocalization procedure that you use already use machine learning, I guess, no? It's based on machine learning algorithms, or not?
No, because this is only the data that we have, and also have
the data, you mean the peaks? The peaks. So okay, so the regional data that you use are not the waveforms, but the peaks that are available.
Yes, in this part, and in the part of tomography, we use the fixed data that we can obtain.
Okay.
in parallel, we are also working in machine learning to localize and to do other things.
Mhm.
But indeed, we have like a finished work that is the tomography and the CNS localization that don't have any intelligence. It's the
Yeah.
normal work.
Yeah, okay. So human intelligence only. Yeah, it should be enough. It should be enough. I didn't get what was the problem with publishing the work.
It's a very stupid thing because some times ago, this review journal asked me for review of the Chilean seismicity.
Mhm.
And I think that this could be a good option to show the CSN catalog. I asked them for this one. But in the review, some reviewers said that this is very original for a review journal.
Yeah.
Then we reject your work. And in this field, we have lost 1 year and a half, almost 2 years. And
That's really stupid.
then we need to think publish in other journal. This is the
Mm.
problem.
Yeah. I see. It doesn't look like a review paper. It's more like an original paper. That's what they say.
This was the reviewer.
Yeah, okay. I know. Yeah. Very unfortunate.
Mhm.
Yeah. Yeah. And Christian, I have a question to you regarding what you show it to us. So this very new thing that you show us combining or the density of each catalog in northern Chile. Do you mean that with that original, would you like to use these 3 different catalogs all together to create one catalog? That's your idea, I guess, no?
I'm not sure if that makes so much sense, but my point was rather that what we want to do with our final product, which should be something like a more homogeneous catalog for, as much of the margin as we can get.
Yeah.
Once we have that, we will want to visualize it, we will want to combine it with other observables and so on.
Yeah, for sure.
But for now, we don't have that catalog. But what I was trying to show is that with what we have, we can already practice or we can already try out these visualizations, combinations, because we already have a lot.
Yeah.
Using those 3 catalogs together is difficult, and maybe it makes even more sense to use something more homogeneous like CSN, because these 3 catalogs have very different station densities, very different time frames. So it would be a bit like comparing apples and oranges. So one would have to be very careful to either adjust for completeness magnitude variations or something like that. So I think for the final science, it probably doesn't make too much sense to do that. But we can already get first ideas that bridge the time until we have something better. I think that was more the statement.
Yeah. Now I understand.
Because the methods will be the same.
Yeah. So what you are proposing is that we should be prepared for the time when we will have the new catalog. No, we should be already prepared in terms of how we will use that catalog with gravity data, logging, etc.
Yes. And we can, in the meantime, one strategy might be to just use the CSN catalog. Another strategy might be to combine like smaller scale with maybe higher resolution catalogs. I'm not sure which one is actually better.
Yeah.
Each comes with its own set of drawbacks.
Okay. But whatever the catalog, the idea for you is to having a catalog, let's try to see how to combine that with the other independent information in order, for instance, to map asperities in the megatrust.
How to combine and also how to visualize. So this was the idea of these density plots that, for example, if you just show earthquakes as dots, if you get upwards of 100,000 in a relatively small area, at some point dots don't tell you anything anymore.
Sure.
So you need something else.
Yeah, I understand. Yeah, I like the idea, of course. And in that case, well, the first step for me perhaps would be more naturally to compare actually the CSN catalog. So the new CSN catalog, the one that you have, Sergio, with those local scale catalogs in order to see how they
Okay.
they compare, no, and to try to actually to have to take a decision about what will be for the next step, no, with which catalog we can work. Of course, we can work with all of them, but it would be great. But for that, Sergio, the question if we can use that catalog that you produced with Bertrand, or you will expect to publish that.
No,
You're
you
okay.
the philosophy is you can use that, all people can use, but only we need to coordinate well. You can publish this very fast, that we don't have problem to publish the catalog. This is the only our objective, and we only need to coordinate to do this well, and also the Bertrand was doesn't have some problem in the publishing.
For sure.
Period.
Yeah, of course.
This is and after, I hope that all this is available. That is very unfortunately we have with this this reviewer comment that's too much original. So
Crazy, really, because they can tell you that 6 months ago, I don't know, or when you submitted the paper, I don't know, when you, yeah, but okay, yeah, okay. So it's good to know that. I mean, that means that, of course, if you give me the catalog to me, I have to promise to you that I am not going to publish that catalog before you publish that, and I will not also share the catalog with anybody. I mean, that's the main point, I think, no?
yeah, something like this.
Yeah, for sure.
We can find some good things for all of us.
For sure. Yeah, no, it's very clear. Very
So
clear.
yeah, in that case, it would definitely make sense what Andres just said. We can start with cross-comparing the different catalogs and see what features are in common and what features might not be. Yeah, that makes sense.
Yeah. So how to proceed with that, Sergio? Do you think it's possible to share it soon with us, or?
Yes, I only need to speak with the Bertrand and to decide how to work, because we have the reject some days ago. Then we need to think where we resubmit, and after we can speak and to have some argument. I think that we can share very soon. We can speak soon, Andres. No problem.
Yeah, perfect. Excellent. Excellent. Very good.
We can coordinate directly next few weeks.
Okay. Great. Yeah, because having the catalog or the catalogs, because we are going to compare that, we should also compile the other information. I mean, for instance, in my case, gravity anomalies, we have the anomalies that we computed with Diego Molina for the paper in 2021, and because there is not new data included, that anomalies should stay forever, I think. And so we can put that also, because I don't know if everybody know, but Nicolas and Martin already did a drive. I think it's a Google Drive, or is an
No, it's an Outlook something.
Yeah, but you created a shared drive to put all the information that we have, some papers and data, etc. And we have access to that. But for instance, I can put there also the gravity anomalies in a grid format or in a table format, for instance, in order to start seeing which kind of data we already have. And as Christian said, imagining also how to compare these different, how to visualize the correlation between seismicity and gravity, and probably Marcos also locking. And I don't know, what do you think about sharing also some grids of locking?
Sure. No problem.
Because I don't know so for this exercise, which is kind of preparing for having an incredible, nice catalog that we can use, no, we can use any data that's available. I don't know which one do you think that could be useful for this exercise, Marcos?
Can be the login.
Mm-hmm.
What else?
Yeah, but whatever the login it is, I mean, because it could be. I asked you if do you think that it for this exercise will be okay if I also put the grid for the Molina's paper, or do you think that we can use something better?
Whatever you want to use, doesn't matter.
Okay, so let's start with that one. I don't know, in order to put it, yeah. From Molina plus gravity in the shared drive. Okay, so perhaps it's a good idea to to start populating that drive. So I will put that data there. Perhaps some papers also will be interesting, and just send you a link to that. No, send you a link to the drive in order for you to see what is the information, what is the structure also. Okay, Ignacia, thanks for being here. See you in the next meeting. And yeah, and you can also share there some data that you think that will be useful, or papers, or etc. Okay, it's that a good plan also?
Yeah, I think that could be quite nice.
Yeah,
it's definitely good.
Okay, so I will try to do that during the week. I will not say today, but during this week. And also I will send you the survey for the next meeting by the end of October. Great.
So should we do it as one meeting with different, let's say, chapters next time, that we just say first part is this, second part is this, that people can come and go when they feel it's best for them?
Yeah, I think that's the best idea, because like I said, for some of us, we will be in several groups, so it's better to have just 1 hour or 1.5 hour in one day that spread in different days. No, I think it's a good idea.
And then maybe after Congresso, we have a bit more focused ideas, because we were able to talk to each other in person, and then things maybe can take off in different shapes. Let's see.
Very likely that will be the case.
Okay.
So great. Perfect. So thank you very much for staying there. These 2 hours, it has been very interesting, and I think we can follow thinking on how to work together. Super. I will send also the link to this video. Okay, so Christian, something to
I think maybe we should mention, because not everybody knows that yet, that we put in a session for next year's EGU.
Oh, that's right. Yeah.
So there will be a session on what was it called? Subduction processes on the western margin of the South American continent at EGU, headed by some of us.
Or we so you, Sergio, Marcos, myself, and Ansu Get?
I think that's how it was. I kind of forgot, because it was a bit of a scramble to the deadline, but I think that was the lineup. Yeah.
Yeah. So great. And
I think once they go into the process of actually putting the schedule together, we should be in email contact anyway for announcing it and all that. But I think that will only happen in November or so.
Yeah,
I'm not sure.
Probably. Probably in in November, I guess. Yeah, when they say, okay, it's accepted as a session, and then we should start yeah.
And then it's about how many abstracts get submitted, whether it actually becomes a session or not. Yeah.
Yeah, but it's very like, I mean, when nothing like this it's on the table, there is many people that put talks in different things, and it's hard
Yeah,
for them.
and I clicked myself through all the session proposals, and there doesn't seem to be anything else focused on,
I
South
think it's
America at
gonna
all.
be a successful session, no? But that's part of the work that we have to do once the session is accepted, and we have to make some publicity. Yeah, but it's coming.
Okay.
Mhm. So at least Jorge and Nicolas, for sure, they will send something. They will send some talks to that session. Let's hope it's the case. Mhm. So, okay, guys. Now I think that we can say goodbye. All right? No. So thank you very much again, and see you soon.
Good.
Thank
Good.
you.
Thanks.
Bye
See
bye.
you.
Bye.